In this tutorial, I am going to teach you how to write and name ionic compounds that involve those pesky little elements from the transition area of the periodic table, and a few are scattered under the stairs. From my experience, I'll be teaching away and my students are just cruising along learning this ionic, and sometimes it's like when we hit those transition metals, everything comes to a screeching halt. And what I want to tell you is these are not hard. I think for a lot of students, they expect it to be harder and maybe they overthink a little bit, but I'm going to make this as easy for you as possible. But don't be stressed about it. These are they're just easy. They're not bad, I promise. So when we've been doing ionic compounds so far, I don't know if you've noticed this or not, but every time to this point, the metals that we've used have come from either groups 1 or 2, meaning you are seeing the same metals over and over. Lithium, beryllium, sodium, magnesium, calcium, potassium, just over and over and over, with a few of the exceptions. Remember, aluminum's always +3, zinc is always +2, silver is always +1, and mercury is always +1. So you have the 3, 2, 1, 1 exception here, always positive because they're metals. But what you haven't seen up until right now are us using very many of these elements, and I call it the D block a lot because I've already taught my students quantum numbers, electron configuration, all that stuff. But we haven't really used much here and under those stairs. And these are the metals we're going to focus on today. The reason they're special is this. They can have more than one ionic charge. You could have copper +1, copper +2, etc., cobalt +1, cobalt +2, cobalt +3. And because they can have a variety of charges, when you write the name, you have to have some way in that name to let the reader know, hey, I'm talking about copper with a +1 charge, or I'm talking about copper with a +2 charge. The reader has to understand which charge that copper had so they know how to write the chemical formula, and frankly, so they know what they're dealing with. So that's what I'm going to teach you to do in these next steps. Now, I've got a couple notes written here for you. First of all, this is pretty much just the ionic naming and writing formulas you've already learned, with just a little extra added for your enjoyment. So here are a couple notes I want you to think about when we talk about ionic compounds with transition metals. We're going to use something called the stock method. That's just fancy talk for we're using Roman numerals. And just as a brief review for you, here are the Roman numerals for 1 through 10. Honestly, I don't know that I've ever really worked with anything above 7. For my students, we're usually in the 1, 2, 3, 4 range with the occasional 5 or 6, but just not much. So if you know Roman numerals 1 through 4, you're fine. Don't stress about the Roman numerals because most people at least know these 10. Now, these are located in the D block, that middle part of the periodic table, and under the stairs, that part I just highlighted for you. We do not use this method for any elements in group 1 or 2. We've already learned how to deal with those. And also, we don't use it for the exceptions, the aluminum, zinc, silver, and mercury, 3, 2, 1, 1. When we're going from the name to the formula, I want you to think about, formula to name, it's almost like you're uncrisscrossing it. You're uncrisscrossing it with your eyes, okay? So you're kind of working backwards. I tell my kids, put on your detective hat. Look at your clues and work backwards and see what was the charge on the metal before it was crisscrossed. That's really the question that you're asking yourself. Because again, Mother Nature is putting these together in a way that results in a neutral compound molecule. So I've made a note here. Just be careful with subscripts that could have possibly been reduced or canceled out prior to the crisscross. For example, this is how we write copper 2 oxide, and you may look at that and say, let me push that up a little bit for you right here. You might say, I don't see a 2, like where's the 2 in there? Well, if you think about it, this copper is in a 1-to-1 ratio with this oxygen. We know oxygen's a -2. By the way, you're always going to know the anion side, and that's you're going to use that to help you figure out what the cation is. If it's a 1-to-1 ratio and I know oxygen's a -2, it makes sense to me that this must have been copper with a +2, because here's what probably happened. Here's what did happen. That copper with a +2 and that copper with a -2 canceled each other out prior to the crisscrossing. But indeed, this was copper 2 before all of this stuff happened. That's why it's copper 2 oxide. Sometimes you may have charges that are actually reducing. Always reduce before you crisscross. Don't ever reduce anything that's already a subscript. That could cause you problems down the road. And again, working backwards. I'll tell you what would catch your attention on something like this, and don't stress if you're not getting it yet, because I've still got to go through the lesson. This is just a little preview. But if this 2 would have come from here, then that means this understood 1 would have come from here. Well, I know oxygen is not a 1, it's a 2. That tells me, something's going on there before it was crisscrossed, and that leads you to the fact that it was reduced. The great thing about these is if they give you a name and you're trying to figure out the formula or vice versa, you can always work backwards and undo it or redo it to see if you were right. It's really easy to double check your work, and I'm going to show you how to do that. So let's start with the name and writing the formula, because I think that that is the easiest place to start. Let's get all set up here. Let me line up. If y'all saw my setup, I'm at my kitchen, in my kitchen office, and I have a super fancy setup here. I've got this iPad propped on a cardboard box with a container of one of my boys' BBs on top holding the iPad in place. So bear with me while I get that nice and straight for you. So we're going to start with ionics, and we're going to write the formulas. So the first thing I notice about these is these are all ionic compounds. How do I know? They all have a metal in them. That's a dead giveaway, and the metal is going to be written first because it's positive. So I know they're ionics. But now when you recognize it as ionic, you have to ask yourself another question. Does it have a transition metal in it? Obviously, all of these do, because that's what the lesson's on. So what this Roman numeral is telling you is literally they are handing you on a silver platter the charge of the metal. You're not even having to look it up on the periodic table, so I think these are even easier. They're saying, hey, this is lead with a +2 charge. This is copper with a +1 charge. The Roman numeral always is telling you the charge of the metal. So again, they're just giving it to you. They're like, dude, don't even worry about looking at that periodic table. Let me just tell you what it is. And that's so nice. So let's look at number 1. Lead 2 oxide. They are telling me that the lead has a +2 charge. That's where I got that. I know oxygen is O -2. We know that like charges cancel. So you're just going to cancel them out, smack them together, and you get PbO. So you're still crisscrossing, nothing new there, and we're crisscross beast at this point. We've got that. But now you just have to know that they're giving you the charge, okay? Copper 1, that's copper with a +1 charge. Sulfide is in the negative. Let's look that up. I don't know if let me look that up with you. Just as a reminder, sulfur is in the -2 column, so it has a -2 charge, just in case you're picking up with a different video or you haven't seen that in a while. That's where we're getting those numbers. Crisscross, remember we do not write ones. Cu2S. Number 3, we have chromium 3 iodide. So we know chromium is Cr. We haven't used that one yet. +3 charge. Iodide is a halogen. It has a -1 charge. I know that again because it is in the -1 column of the periodic table. I bring the 1 here, the 3 here. I get Cri3. That's it. So they're just giving you the charge and you're crisscrossing. I do want to remind you that when you're working with ionics, you will never have a charge down here. No pluses, no negatives, only numbers. We do not write ones. They are understood, and you will never have numbers up here as superscripts once you have written a chemical formula. Let's look at number 4. Iron, that is Fe. It has a +4 charge in this case. Oxide is O -2. This one's got something special going on. Do you know what it is? When you look at it, what do you think I'm going to do here? I'm hoping that you see these can be reduced before you crisscross. This is going to reduce to a 1. This is going to reduce to a 2. So when you crisscross, you get Fe1O2. So when you're going backwards later and writing the name, this is one of those you would have to be careful with. And what's going to draw your attention to that is the fact that if this matches to this, like for example, this is a 1. Should you have a 1 up there? No, that should have been a -2. If those don't match, these aren't going to match. It means something was reduced prior to crisscrossing, but you can very easily figure that out. And remember, you're just working with real small numbers. You could even use some trial and error if you had to. I want you to copy 5 through 10 and pause for a second, try them, and then take a look back, and I'm going to walk through the rest of them, and we will make sure that you've got this before we go the other way. So, number 5, cobalt-2 bromide. Cobalt has a +2 charge. That's a big C and a little O. That's real important because if you wrote big C, big O, you would have carbon monoxide. Bromide is Br -1. Crisscross, you get COBr2. Number 6, gold-1 oxide. Gold is Au +1. Oxide is O -2. Crisscross, Au2O. I know, these are fun, right? I love them. All right, let's look at number 7. Copper-2 hydroxide. Now, all of a sudden, some of you may put the brakes on a little bit and said, oh, Lord, polyatomic ion. Some of you might have gotten really excited. I love these too. You do the same thing. Just remember, back to our ionic lesson, if you have a polyatomic ion, remember your 3 P's. Protect the polyatomic with parentheses. Even if it's one like hydroxide that does not have any subscripts, we know hydroxide is OH -1, you still got to wrap that thing up in some parentheses to protect it. So copper has a +2. Hydroxide is OH -1. You crisscross, you get CuOH2. 2 has to be outside the parentheses. Is that important? Yes, it is absolutely essential that you do that. I will show you the no-no way. So if you've got room, you might want to write this down. What you don't want to do is CuOH2. That is incorrect, and it's incorrect because it did not have the parentheses. All right. Let's look at number 8. Lead-3 perchlorate. So lead is Pb +3. How do I know it's +3? Because they gave it to me because they're being so nice. Perchlorate is ClO4 -1. You're going to have to wrap that polyatomic ion in parentheses, so you get Pb, ClO4, running out of room here, 3. All right, we have 2 more, and I just feel like you've got this. So number 9 is manganese, not to be confused with magnesium. Manganese 2 phosphate. I'm just going to put the charges right here in the interest of saving some space. Manganese is Mn. They're telling me it's +2. We know phosphate is PO4 -3. When we crisscross, we're going to have to be sure to wrap that up in parentheses. So we're going to get Mn3, because that 3 is coming down here. Wrap up the phosphate, PO4 2. That's a lot going on, but it's easy. It's not hard at all. And the last one, tin 4 sulfate. Tin is Sn +4. Sulfate is SO4 -2. This is where you've got to be careful. These can reduce before they are crisscrossed. So 1 and 2, Sn, SO4, and that 2 comes down here, and you're done. Lots of great information there. Really, this was just wonderful practice on writing ionic compounds, because you weren't doing a lot new here except for recognizing that, hey, they are giving me the charge, and that's fine with me, less for me to do. Now we're going to go the other way. And this is going to require just a tad more brain power, not much. Don't be scared. You'll probably enjoy it. You'll be like, why have I not loved this before? So let's take a look at going the other way. Now what I want you to remember is this. All ionics end with IDE unless they have a polyatomic in it. Nothing has changed there. What we're trying to do here, you know what? I think I'm going to flip to another color Sharpie. I've got like all kinds of colors over here. I need to be using them just so you can maybe see my work in comparison to what I've already written down. And if you want to pause here and like maybe go ahead and copy these first 7, 8, that's fine. And then you already have those written down as we go through them, and then pick back up. And then I'll put the last few up for you. So I've got, this is what I would look at. I know it's ionic because they're all metal, not metal. Every single one of these is a transition metal. That means it's in that middle block or it's under the stairs. Or you could say these are not group 1, 2 elements, which you've probably about memorized all those by now. That means I've got to use Roman numerals. As soon as I recognize transition metal, transition metal, transition metal, so on and so forth, I'm going to need to use my Roman numerals, because I've got to let the reader know which copper is that. Is it 1, 2, or 3? About 95% of the time, you literally are going to be able to uncrisscross these with your eyes. And here's what I mean by that. If whatever is down here beside of your cation matches what would have been the charge of this anion, you're golden. You can just uncrisscross it. So that's an understood one, right? Did chlorine have a -1 to start with? Yes. It's very clear this 1 came down here. That means this 3 had to have come from up here. So this was copper 3 chloride. Now, let's say, gosh, I'm not sure if I'm right. I'm not real confident in these. Just write it out and see if you're right. Look at this, copper with a +3. Okay, so let's say copper had a +3. I know chloride's a -1. The anions aren't changing. You're going to know those. I'm going to crisscross. That gives me CuCl3. Yep, I was right. That took a second. And you can now be confident that your answer was correct. If you miss it, you'll probably learn a lot from that, and you'll know how to fix it. So let's look at the next one. I know this is iron something bromide, so I could go ahead and write that down. IRON something bromide. Okay, so what was that iron before that crisscross took place? That's what I want to know. Now, I know bromine's a -1, and the 1 came down here, so those actually, it matches from here to here, -1 and a 1 came down. That means this 2 had to have come from up here. So that was iron to bromide. Let's check it and make sure we were right. Fe has a +2. Bromide has a -1. Crisscross. FeBr2. Yes, it matches. And I was correct. Now what I'm really hoping is happening here is some of you are like, oh my gosh, I don't know what didn't click the first time, but I've got that. And the good news is we have 8 more to practice, so you'll definitely have it by the end. So let's look at this next one. CO is cobalt. That's going to be fluoride. That's a transition metal, so I know I'm going to have to use Roman numerals, so let's just go ahead and write down what we know. Cobalt, something, fluoride. All right, fluorine has a -1. There is a 1 here, so this to this matched. That means this 3, once again, had to come from up here. So cobalt, 3, fluoride. Because I'm an overachiever, I'm going to check it just to be sure. Cobalt has a +3. Fluoride has a -1. Crisscross, COF3. Boom. Good job. Okay. Let's look at number 4. Ni2S. I know that is nickel. It is a metal. Is it a transition metal? So I'm going to have to use Roman numerals, and that's going to be sulfide. So I'm going to write what I know. Nickel something sulfide. All right. Now, I know that sulfide has a -2 charge, and that 2 did come down here, so these match. That means whatever was here must have been up here, and that's an understood 1, so that should have been nickel 1 sulfide. Now, sometimes these, I don't know why, but when you put the 1s in there for beginners, they look a little bit odd, so just check it and be sure. Honestly, double checking's even good for me. I've done this for a long time, but sometimes I make a mistake. Ni+1, S-2, crisscross, Ni2S. Yeah, looks odd, but I was right. All right, number 5. Ti is titanium. I is going to be iodide, and again, I'm sure you noticed, but I'm going to point it out. They are all ending in IDE. So let's write titanium. Okay, something, iodide. All right, I know that iodine has a -1 charge. So it came down here, and that's a 1. This matches to this. -1 and the 1 came down. That means that 4 had to have come from up here. So that is titanium 4 iodide. And again, you could write it and check it. I'm not going to do it on this one. I may do it on some of these coming up though. Okay, so these are all binary ionic compounds with transition metals. We are going to continue with the same thing, only these are not binary. These are ionic compounds with polyatomic ions in them. They have transition metals, so I'm going to use the stock method, and everything else is exactly the same, just like what we've been doing. Don't let these extra little letters in here shake your confidence. You know how to do it. So number 6, I see copper and I see hydroxide. I'm like, that's transition metal, so I'm going to have to tell my reader which one. So let's just write what we know. Copper, something, hydroxide. Okay. Now, hydroxide, and this is just my scratch work right here. I know hydroxide overall had a -1 charge, right? And that 1 is what's down here. So those match. That means this 2 outside of the parentheses came from this copper. So this was copper 2 hydroxide. Let's check it just to be sure because this one's a little different. If copper is a +2 and hydroxide's a -1 and they crisscross, I'm going to get CuOH2, and I was right. Let's look at the next one. Now this one has chromium and then the polyatomic ion chromate. So let's write what we know. Chromium something chromate. Now, I know that this is a polyatomic ion. And this whole polyatomic ion right here, I know it had a -2 charge. Since this is in a 1-to-1 ratio with this, there's 1 chromium and 1 chromate, that leads me to believe this must have had a +2, and they probably canceled. They canceled, and then we just smacked them together. So my guess is this was chromium 2. And at this point, for some of you, that might be exactly that, an educated guess. So let's take a look at that. If chromium had a +2 and chromate, CrO4 -2, we know that with ionics, if the charges are the same, they cancel, smack them together, CrCrO4. And we were right. The worst thing that's going to happen if you double check yourself is you missed it. And if you missed it, you're probably very easily going to be able to fix it. So let's look at these last 3. This is iron something phosphate. Again, I see I have 1 iron and 1 phosphate, because this is just one thing. There's no parentheses around it with a number outside to indicate I have anything more than 1 phosphate ion. I know that phosphate had a -3 charge, and if it's in a 1-to-1 ratio, that iron had to have had a +3. That's the only thing that makes sense because they canceled each other out. So I think it's iron 3, but I'm going to check it. So Fe +3 and PO4 -3, you can see the 3's cancel. You smack them together, FePO4. I was right. And we have 2 more. And I specifically put these together because I wanted you to see the difference of what happens when you have a number outside the parentheses as opposed to a polyatomic ion with no number with it outside the parentheses. So we're going to look at this first. I know this is cobalt something nitrate. Okay, so I know nitrate as a whole has a -1 charge. And it looks like that 1 is what transferred down here because the cobalt also has a subscript of 1. This matches. That means this 2 outside of the parentheses had to have come from up here. This had to have been a +2. I'm going to check it. If cobalt would have been indeed a +2, and we know nitrate is NO3 -1. When you crisscross, you get CONO3 2, and that was correct. So the number that was up here, if there's anything with parentheses, the number outside of the parentheses is what came from up here. Again, just uncrisscrossing. And the last one, this is also cobalt something nitrate. And isn't it wonderful when we know our polyatomic ions? It's just like you're speaking the language. Now, this cobalt, let's see, nitrates, I'm just thinking through it like you would. You might even do it this way. You might say, okay, that's 1 nitrate, and it has a -1 charge overall. And you might even make a little note of that. I've got 1 cobalt. If that's a 1 to 1, it makes sense those 1s canceled before you crisscross. So I think it's a 1, but I'm going to check it out just to be sure. One more time. Cobalt plus 1 and nitrate minus 1. The 1s cancel, smack them together, CONO3. You were right. And you now know how to work with transition metals in an ionic compound. That was a lot of examples, so hopefully you're feeling really good about that. This has been my most requested lesson to go back over so far from my personal students. We were just really kind of doing this before the pandemic hit and school stopped. So I'm hoping that this will really get some of you on the right track. So again, these were the notes. If you want to pause it here and write this part down, and then I'll scoot it up. And so after you've done that, you can also see the bottom half. That's a really good overview. The next thing that I will be teaching is naming acids. Super easy. And then I will probably put together some activities where we're just